Hey guys, Mr. Aguilar here. Hope you guys are doing good. I'm sorry it took me so long to update this video. We're going to be reviewing today a little bit of graphing. We'll continue this on Friday. Just probably a little worksheet and going over the material that we did today. You do have some homework problems. I'll be going over 2 of them. You have 12 of them. They're not going to be that difficult. As you guys can see, we're looking to look at the 3 different types: slope-intercept form, standard form, and our Hoy-Vux, which is our vertical and horizontal lines. Reviewing this material for us, it's kind of important because the next things we're going to do is systems, which involve 2 equations, and we want to make sure that you guys are well prepared for those. Looking at the test, I'm still grading them. I plan to have them updated by today, this afternoon. So keep a lookout for them, if not Friday, and we'll talk about them as well. So let's go ahead and get into the front of it. The first one we want to talk about and do is our slope-intercept form. This is the one that you guys are going to see the most of and see a lot how to actually do them. The first part of this is identifying what each part means. M is our slope. We always want to define it as that. And we always know it to be our rise over run. Okay. It is also change in y over the change in x. Okay. The other one that we're going to look at as well is our b term, and our b term happens to be our y-intercept. It's where the crosses the y line, where it crosses our y-axis for this. So we'll look at several different types and apply them as we do them. If we go to a problem down below that, just so we can kind of get this idea of how to actually graph these, let's go ahead and create a problem for you guys to graph. And I'll be doing several more, so don't freak out. This will be y is equal to 2 over 3 x minus 2, just something very general so we can see how to graph it. I'm hoping you guys are following along for this as well. If you guys need to stop, pause it, reverse it, go back, look at the material. But this is all review. The first thing we want to be to identify 2 different things. We know that to be our slope. The slope is our rise over our run. And the second term, or this -2 term, will be our y-intercept. So I want to make sure that we're graphing our y-intercept correctly. First things you want to do is, as you guys remember, we're going to go down to -2, where it crosses our y-axis. And then the next thing we're going to do is apply our slope, which will be up to over 3. So we're going to end a point there. If I can get it. Over 3. Again, remember that negatives go down or left, depending on how you want to write them. And let's continue this idea of going up to over 3 for our next point. And then back 3 down 2. And just keeping this idea of graphing all of our points. And it will help in the future when we do these. The next thing we want to be able to do is graph them and create a line through these points. So this would be our slope and our y-intercept that creates our linear line. So that's just one of our ideas that we have here. So let's continue this idea. That was one part of the slope-intercept. That's our rise over our run again. We're going to be applying these a lot more. So you guys definitely want to be able to do these. Our standard form is the other version. We're going to be using this in a lot of substitution and elimination methods. So I just want you guys to be able to see it. It follows from the same idea that we're getting our terms in standard form. There was 2 ways of solving them out. We have 2 ways. We had the cover-up method, cover up, which is cover up x, find y-intercept, The second thing would be to cover up y, find x-intercept. And some of you guys might forget this, and we're going to go and do both of them just so you guys can see them. But again, I'll leave it up to you guys. The other way to do this is to convert. So solve for y, solve for y, which will turn it back into the slope-intercept form, the problem that we just kind of did. And I'll show you on that one as well. The last way of doing this is to find your slope and your y-intercept term. In this case, if you know your a, b, and c, your slope for this case will be negative a over b. If you just want to find those two terms and plug them in that way, that'll be your slope. Your b, or your intercept, right, not the capital B, but your smaller b, will be pretty much the same thing, except it's going to be c over b. And I'll show you again what I mean by those. I'm going to show you all the three different ways. Whichever way works for you guys, it does not matter. No work, no credit, as we always say. So keep that in mind as we do these. Let's pull out a problem. Hopefully I can think of one that will be pretty constructive. Let's do it several different ways. I'm going to cover up the problem to the right, just so we have more room. And then I'll clear it when we're done, so you guys can see how we're kind of doing all these different types. This one's the longest one out of all of them. Just find whatever makes you comfortable in solving it out. So let's get a problem. Let's say our standard form equation was 2x minus 3y is equal to 12. Let's just say 12. Two ways of doing this. The cover-up method, right? If we cover up our x term, we're left with just our negative 3y is equal to 12. So this will give us a value of y value of negative 4. So we're going to graph it at negative 4. I'm going to show you the three different ways. If we cover up the x term and leave our y term, we're going to get 2x is equal to 12, which x is equal to, in this case, 6. So we have our 2 points. I believe this is the easiest way, but it's up to you guys to really kind of figure that one out. I'll let you guys kind of figure how you guys want to graph that one. This is the cover-up. This is method 1. Method 2 would be just to convert it back into a slope-intercept form, which is 2x minus 3y is equal to 12. So to solve out for y, essentially, we're going to go ahead and subtract 2x, giving me negative 3y is equal to negative 2x plus 12, because I brought the 2x to one side. And then we're going to go ahead and divide everything by 3. So we're going to get 2/3 x, and then negative 3 goes into 12 negative 4 times. So if I had to graph this one, we'll show it in a different color. We'll do it in orange. But it follows from the same idea of how to graph this. So we're going to go down 4, which is our intercept, and then up 2 over 3, which is another point. Up 2 over 3 gives me our third point. We graph the same line on this one. So that is the second way of showing this. Let me get you a better line on that one. That's another way you could do this, to convert them. And they're graphing the same line. These are just three different methods. The final one, and the third method, which I didn't even write, is just plug it into the equation. So I'm going to kind of go ahead and do that. Our m is equal to negative a over b. And our intercept is c over b. If we were to plug these in, and just using our equation 2x minus 3y is equal to 12, I get that capital A is 2, B is negative 3, and we get C is 12. So if we were to plug these values in, let's kind of zoom in on this one. We're going to get negative 2, right, that represents our A. Our B happens to be -3. So our slope in this case will be 2/3. So that's one of our key things. And then the y-intercept would have been our C is 12 and our B is -3, which gives us -4. Whatever method works for you, we'll review this on Friday. I'll ask you guys the same kind of questions. And then how we want to be able to do this one is just as we did the other pairs. Our y-intercept, right, problem goes down 4. And then we have the rise over run, which is 2/3 again, giving us the same slope, giving us the same line as we just did. So keep that in mind as we do these. The standard form equation is one of the biggest ones you'll see. Not so much a point slope, which I'm not even going to go into that, but just kind of keep that in mind as we do these. It's kind of important that you go in between both of them, both slope-intercept standard form, and we're going to talk about the Hoy-Vux version in just a moment. So keep that in mind as we do these, guys. I hope you guys are getting these all down. So again, if you need to stop, reverse, look back, and then we'll apply them. I'm going to clear this a little bit, getting rid of this. So if you guys need to pause it now, copy down what you need to, revert back. But I want to make sure I have everything on the same page for this one. So this will be our standard form now. Or sorry, not our standard form. Our Hoy-Vux, which is our horizontal and vertical lines. Okay, horizontal and vertical lines. And I'll erase that one, rewrite it. I think we had it as 2x minus 3y is equal to 12. So leave that one on there for you guys. Our Hoy-Vux, which is some of you guys are new to this, because I didn't have you last semester, they're used as acronyms for several different things. Hoy stands for horizontal, slopes of 0, which makes our line go left and right because there's no up and down, for all values of y. So any y value, any y number does this for any y numbers. That's a horizontal line that provides us these. I'm hoping you guys remember these. I told you we're going to look back at them. Our Vux is exactly the opposite. Vux means vertical. So it's vertical lines. Our slope would be, M would be, the big U means undefined. So UND means undefined, meaning we can't define it, meaning it goes up and down. We can't tell what that slope is because we don't know the direction it takes on. So that's what we say it's undefined as. And then for all values of x, so any x that's equal to any number. There's no other y terms. It's a single variable. X is equal to 3, x is equal to 2, x is equal to 1. Those are the kind of numbers we're going to look at. So let's kind of look at properties for these, or actually drawing these out. Let's get 2 problems on here. We'll do one in blue and the other one in red. So we'll start out with red first. Let's do y is equal to -2. And we'll do several of them. How about that? Y is equal to -2. So this follows the Hoy version, H-O-Y, y values at -2. So our y-intercept in this case happens to be down here at -2. It is a horizontal line, so we know it to be flat. Or say left and right. I'm going to draw several of them on here, so don't freak out. Let's look at another one. X is equal to 3. So this follows, it's an x value, there's no other y term, it's by itself, so we say it's a Vux, so it's a vertical line for undefined slopes for all values of x. So we're going to go at V here, and it's going to be a vertical line. Vertical goes up and down for these. Okay. So those are how we want to be able to see it. We'll do one negative, one positive. So we'll go back and do another y1. Let's do y that is a positive this time. And we'll say, we'll give it 5. We'll give it a big number, a bigger number than what we've seen. Again, y is equal to 5 becomes a Hoy type of problem. So horizontal line for our y value at 5. And then it should be horizontal. So we're going to go left and right from this. Okay. So that's how it should look. It should be a horizontal line. And then our final one, let's go ahead and do pink. Let's pick pink. And we're going to do x, an x value. Let's choose one. Let's choose it to be -3. We'll try -3 for this one. +3, -3. So this follows Vux, which is a vertical line at -3 for any value of x. So there we go. So those are the different types you want to be able to see and do for our type of problems on these. So keep that in mind as we graph these different types. So again, this should all be review. I mean, you guys need to get good at this. So please take the time and actually practice these problems. Throw in your earphones, listen to some music, review it if you need to, and then come back and solve the problems. These are very important. Okay. So let's look at some problems. I believe I'm going to be doing at least 4 of them, and then we're going to come back and show you what you're really doing on the back side of the homework. You're given 2 equations. I just want you to graph them and tell me where they intersect. I want you to tell me the coordinate points, and this is going to get into the idea of systems. Right? A system is a 2 equation type of solving part where you're finding solutions of intersections. We'll get to that. Here we go. Next one, so let's see. Here are the ones you want to look at. So here we go. Perfect. First things you want to do on these is just being able to identify. We have different types. We have the first one being slope-intercept. The second one to the upper right happens to be a Hoy-Vux type of problem. And then the bottom left happens to be a standard form. And then what you see in the bottom right is what we're going to be doing. And I'm going to be doing 2 of your homework problems for you guys today too. I believe number 1 and number 11. So let's get to it. Let's get this started. Hope you guys are having a good day today. I know it might be the morning or afternoon, but think about it. Tomorrow is Friday. Yay. Okay. Here we go. This is our slope intercept. So I'm going to go and highlight a bunch of these and lift enough from. So this is slope intercept. As I'm writing these down, I just want to let you guys know the test grades are going to be very well. So far, I've graded 1 through 5. I plan to finish them up tomorrow. Just got to tally them. 200 kids, it's a lot to grade, so give me some time to put them in, and they'll be updated. But I've seen a great turnaround for the ones that actually did it. I saw some great half sheet of papers for the ones that actually took the time to study. I hope the test wasn't that hard. There were several questions on there that you guys had to do, so keep that in mind. If you have any questions, please see Miss Reyes. She'll be more than happy to help you if you need to. Okay, here we go. So slope-intercept form right here. Let's go ahead and identify a few things. Our slope, or let me write this back. Let's do y is equal to mx plus b, and let's go ahead and write our slope right underneath it. So y is equal to -1 over 4 x plus 1. And we're just going to identify these parts to them. In this case, our slope had to be in the same position. So I know that my slope happens to be m is equal to -1 over 4. And then my b for my next case happens to be our b plus 1, which is b is equal to 1 for our y-intercept. So always look at your y-intercept first before we graph it. Starting this up, let's graph it. Going up 1 to our y-intercept at b. And then we got to do our slope. So because it's a -1, that tells me to go down 1. And then we're going to go over 4 for our final point. So between 2 points, we do want to be able to graph it. Again, I'm going to have you guys fill in a little bit more. You can follow the same kind of slope that does all this up this way. So we're going to go back for up 1 to get another point on this. It will be very beneficial for you guys to do them today, just because some of your points, whether you're going to intersect, is going to be very crucial. They might be off a little bit if you do not graph them correct. So make sure you guys have those all in correctly. So slope-intercept, done. Just wanted you to graph it. You know, you're going to have quite a bit today, just 12 problems, but you do want to be able to graph them accurately. Next one right here, this follows from our Hoy-Vux. In this case, it would be a Vux protocol. Vux being our x value, which is represented in our problem here. It tells me it's going to be a vertical line, which means up and down. Our slope should be 0, and in this case, our x value happens to be just 4. So I'm going to look on my x-axis because it's an x value. I'm going to go to 4 here. Boom. And in this case, it will be going up and down because it's a vertical line. Okay. Hoy would be horizontal or sideways, so keep that in mind as we do them. Polyvox is a crucial thing. You guys need to know how to do that, okay? Especially next year as well. On the next portion of this, we're going to look at 4x plus 3y is equal to negative 12. This is our, hopefully you guys can remember and beat me to the punch. This is standard, and I'm going to use that little mark, ST, and standard form. Mr. Bixby will be here on Saturday. Tentatively, I do not know where he's at yet, but he said he will be. I believe this is his last Saturday school, and he'll be available. So keep that in mind. Sorry, let's go ahead and continue. Our standard form, I do not know which ones you guys want me to do it in which way. So I'm just going to show it in all the 3 different ways. When it gets to the other problems, I'm going to do it a certain way as we kind of go. The first one way that we did was a cover-up method, and I'm going to show you both methods, or all 3 methods. Okay. So this is our standard form. This is a way to solve for your intercepts. If I cover up my x-intercept, I'm left with my equation 3y is equal to negative 12. How do we solve that out? We divide both sides by 3. We're going to get y is equal to negative 4. So that's our y-intercept. So that tells me to go down negative 4 for my first point. Okay. The other one, if we cover up the y term now, we're left with 4x is equal to negative 12. Okay, that's how you want to be able to see these. X would be equal to negative 3. Okay. It tells me to go back 3. And those are my 2 points. So I can go ahead and connect them down below. Just like that. Again, graph it as accurate as you possibly can. There's rules up in front of the classroom. Make sure you guys go get them. The other way to do that, right? The other way is we have this 4x plus 3y is equal to negative 12, which we're going to be able to convert back into point slope form. So let me kind of separate these. Or slope-intercept, point slope. Form. Slope-intercept form. So we're going to go ahead and subtract out 4x from both sides. And I'll show you all the work on this one. Our x's are going to go away. I'm going to be left with 3y is equal to negative 4x and 12 cannot be reduced. So I'm just going to rewrite that as terms. And then our last bit of thing is to divide both sides by 3, or each term by 3, which will give me my final equation. Y is equal to negative 4 over 3x, and then 12 goes into 3 4 times. So again, you can do this the same way. This would be going down 4, and then I'm going to go ahead and go up 4, back 3, which gives me my other point. I'm done. That's the same graph that you're graphing here. The other ways to look at this as well is to identify the equation. So this is our last version. I'm hoping I'm going to have enough room here. Get rid of that bottom line down here so I can help us out. I'll write it down below for us. We're given the equation 4x plus 3y is equal to negative 12. We know a to be 4, b to be 3, and then c to be negative 12. With our equations, remember, you guys can also give me the equations. Our slope in this case was our rise over run. So it'd be negative a over b. In this case, it was negative a, or negative 4 over b, which is 3. So this would be our slope as it was in our point in our standard form equation. And then the other one to find our b, which is our y-intercept, would have been c over b. In this case, negative 12 over 3, which happens to be negative 4. So that's your intercept as well. Graph those 2 points, boom, plug them in, get the same image on them. So however you want to do it, the first 2 methods we've shown you a lot, so kind of take those in as we do them. Let's get to the main idea. This is the main idea from these, and I'm going to kind of do these fairly fast just because you guys need to be able to kind of get them a little bit faster to them. If you really need help, a website that you can use, and it will help you to graph some of these. I do want you to show work for some of them, but if you need to check your work, type in desmos.com, and it is a graphing um, emulator that you can plug in your values, and it should give you the graphs of where they intersect. So use this later. I want to see all your work for some of these. Tell me what your slope is, tell me what your intercepts are, and then for the standard forms, show me the work for either the cover-up method, you converting. So whichever one works, but I want to see work for these. Um, but the Desmos will help you graph them. First things here, we have -4, so I'm going to tell me to go down 4 in this. And then the second part of this tells me to go up 7. So 4, 5, 6, 7. That's 7 here. And then tells me to go over 2. So that's our graph here. Trying to graph this as accurately as I possibly can. Trying to give me a straight line. It will be crucial. We're finding where the two intersection lines meet. So next one happens to be +2. So it tells me to go up 2 for this one. And then up 1 over 2. And we're going to continue this idea of up 1 over 2, up 1 over 2. And if I can graph this line here, the blue line, okay. Now, the one thing that I want you guys to get for your answers is the intersection point between the two graphs. So where do the two graphs meet? And this is going to be kind of crucial. Just asking, this is kind of like asking just a question, an additional question. So it happens to be 2 comma 3, where our 2 is our x value, our y is our 3 value. So keep that in mind as we do that. So these are the main focus ones that we're going to be doing. You have 12 problems. Each of them are going to require that you graph them. I'm hoping this is how fast you're going to do them. So that is what we're going to look at. Cool beans? Cool beans. Let's keep on going with this idea, guys. Almost done here. 2 more problems, and then you guys can go ahead and do your work. Here we go for this one. So this is problem number 1 for your homework on your backside. So if you want to flip this over and do it with me, by all means, go ahead. If you want to pause it and test it out, I highly recommend that, just to see if you understand the concepts for these. Excuse me. First one here, we have 2 slope-intercept problems. So we have 2 slope-intercept graphs, and we're going to find where they intersect using our graph. So looking at the top one here, we have our +2, which is going to tell me to go up 2. And then I hope you guys remember that our slope for this one, even though there's nothing in front of it, we can always picture it as 1 or 1 over 1. So we're going to go up 1 over 1 every single time on these, graphing our line through these. Hopefully I can do this. So we'll get you a thicker line here so you guys can see a little bit clearer. So that's our first line. That's our equation right here. The second one that we want to be able to graph here as well is going to go down 4. So I'm going to go down 4 on this. My y-intercept again, our b case. And then the next one's telling me to go down 1 over 2. So this is our slope for this equation here. That's our slope. So it tells me to go down 1 over 2. And then we can go back to up 1, back to up 1. Once you see that intersection line there, let's go ahead and get a little bit bigger line. And we'll go through all those right there. Okay. Our solution to this set is where they intersect, and this is where I want you guys to find out. It's our point of intersection, which happens to be, let's make this a little bit bigger, which happens to be this intersection point. So just tell me what the coordinate point for that is. In this case, we're going to go back 4, down 2. So keep that in mind. Okay, keep that in mind. Cool beans. Cool beans, guys. Cool beans. One more problem, and then we're done. I'll let you guys do what you guys got to do. Okay. So clicking here. Boom. This is a combination of a standard form equation, and we have another one being a Hoy-Bucks type equation. So let's kind of figure these ones out. Kind of crazy. Let's check them out. The bottom one would be the easiest one to graph out. This is Bucks, right? Because it has an X value. So a vertical line at -4 is probably the easiest one to graph. It's a line going vertically up and down at -4 for our value of x. So should be able to do that by now. Horizontal will be hoy, but let's continue. The next one I'm going to be doing is I like the cover up method. So x will be equal to 8 if I cover up my, or -8 if I cover up my y term. And then if I do it the other way, cover up your x term, 2y is equal to -8 or y is equal to -4. Check your work, check your answers for those. Graphing these two, it seems like our x is a little bit off the page. So we're going to try to make sure everything's working on that. My first one to do is my y of -4. Let me go back -8, 6, 7, 8. Looks like it's barely off the paper. So I'm going to try to do these. So let's see. Let's see. Right there. And we're getting an intersection point. I'm hoping you guys can see that being our point of where they both meet right here. And this happens to be -4, comma, -2. Again, this one was a standard form equation with a Hoyle-Bucks intertwined. Use the cover-up method, use the solving for y if you need to. I'll give you the y equations. This will be y is equal to, this will be method number 2. This will be y is equal to -1/2 x minus 4. -1/2 x minus 4. The equations for these for the slope would be -a/b or -1/2. You got the a and b. And then their smaller b, which would be c/b, would be your equation c, or -8/2, and this would give you a -4, which corresponds to the standard form or slope-intercept equation that we're given. So gives you both of them. If you just want to get them that way, it's cool to do it that way. Okay, that's all I have for you guys today. Go ahead and finish up the backside of this paperwork. Review it if you need to go back. We'll cover this a little bit more, just probably practice. No quiz tomorrow. You guys already took a test this week. I know you guys are a little bit drained, so I want to start back this on Tuesday, Monday, Tuesday, with more practice. So you guys have a good day. We'll see you guys on Friday. Okay. You guys have a good day. Bye, guys.